Hello everybody, we are Carlos Rojas, Jorge Ardila and Fabian Romero, and we want to explain a little bit about creep process. Introducing the creep process, it occurs when a dislocation happens in the crystalline structure of a material, when it is stressed by an external force. This process absorbs external energy and changes it into internal motion energy, so that the dislocation climbs all around the structure until the structure takes its original form and all lattices that were changed because of the dislocation reach the equilibrium distance. Dislocation clamping consists on a layer of atoms moving through and reorganizing the structure, meaning it needs free space to occupy.
In this case, as you can see, the point of defect is caused by a dislocation. This type of defect can be solved modifying mechanically and thermically. With this modification, the characteristic of the crystals change too, providing hardness and several material properties. And a uniform distribution and eliminating point defects, in this case, makes the structure stronger. The dislocation, as you can see, in this case, the structure starts to change following a sequence between columns with a mechanic force. This kind of point defects can be found in BBC and FCC cube structures.
The doped materials have a clamping with specific characteristics. The distance bonds between the atoms is modified due to the difference of size, generating stress between the atoms that compose the structure. This makes that the necessary energy to generate the clamping have to be bigger than the energy used to the clamping of a non-doped material. That's why the materials with a crystalline structure that was doped have a bigger resistance to the deformation. In the pictures, you can see how occur a dislocation of a cubic structure in 2D with an atom of bigger size. The dislocation starts, the bonds between the atoms change until it reaches the equilibrium.
In hexagonal structures, mid-atoms are taken away, leaving a space inside the hexagon that needs to be occupied by another atom in the structure. This atom moves together with his bonds. These atoms start to move, filling the blank spaces, producing the layers climbing until the equilibrium is reached. In the motion movie is shown how the movement works, going up and down in layers to fill the blank spaces. Creeping in hexagonal structures require a lot of energy because of the complexity of the moves and the amount of atoms and bonds that are reorganized.